Hi guys, and welcome to another video. And in today's video lesson, we're going to be looking at grade 12 maths Euclidean geometry, ratio and proportion, and the midpoint theorem. And the question that we're going to be looking at is from the May-June 2019 examination paper. It reads as follows. We have question 8, and it says, in the diagram, O is the center of the circle and LOM is the diameter of the circle. ON bisects chord LP at N. T and S are points on the circle on the other side of LM with respect to P. Chords PM, MS, MT, and ST are drawn. PM equals to MS and MTS equals to 31 degrees. Now, the first thing that we have to take note of is what is given to us, because remember that what is given to us will be used as reasons in our solution. O is the center. Now, with regards to center of the circle, remember, angle at center is 2 times angle at circumference. If a line is drawn from the center to the midpoint of a chord, it's perpendicular to the chord. If we have a line which is drawn perpendicular from the center to a chord, it bisects the chord. So we must know now all the center theorems. Then when we talk about LOM is the diameter of the circle, remember when you have diameter, remember that you must remember that you have angle in semicircle. Okay, so any line that's subtends an angle at the circumference equals to 90 degrees. So if a diameter subtends an angle at the circumference equals to 90 degrees. Also, a diameter gives rise to radii. ON bisects chord LP at N. T and S are points on the circle on the other side of LM with respect to P. Chords PM, MS, MT, and ST are drawn, and PM equals to MS. So we're given here equal chords. Now remember, equal chords subtend equal angles at the circumference of our circle, and MTS equals to 31 degrees. So let's have a look at this. Now, before we even start to answer any of the questions, we must try and solve the diagram as far as possible. So let's see if we can do that. So if I look here, 31 degrees here. Remember now, equal chords subtend equal angles at the circumference. So that's going to equals to 31 degrees there. Also remember that the angle at center is 2 times the angle at the circumference. So if this is 31 degrees, then this has to be 62 degrees. Angle at center is twice the angle at the circumference. Then the other thing is that I have here line which is drawn from the center to the midpoint of a chord, and there's a chord LP, which means that this is going to be 90 degrees there. Okay, so N2 equals to N1 equals 90 degrees. Remember that we have a line which is drawn from the center to the midpoint of the chord, therefore it's perpendicular to that chord. What else do I have? Well, I have a diameter here, and the diameter subtends, remember, a 90 degree angle at the circumference. That's angle in semicircle. What else? I got radii. LO is equal to OM. So what we have to make sure that we do is solve the diagram as far as possible. And you will see that when you do that, that most of the questions will already be answered. So basically, you're just going to be writing down the statements that you've already said by inspection. So let's go and see if we are able to do that. Determine with reasons the size of each of the following angles. MOS. So if you go look at MOS, it's already done, 62 degrees. So we just need to write that statement down. L is 31 degrees. We've already got 31 degrees there, so that's also done. So we just need to write the statement down. And let's look at, prove that ON is half of MS. So if you look at proving ON being half MS, so let's go look at that. Where's ON? Well, there's ON here, and we want to prove that it's half of MS. But what are we given? We are given that PM here is equal to MS. Okay, so therefore now, remember that that's radii there. So let's just call it, or rather make it different symbols to denote that they are equal. So PM is equal to MS, we're given that. But if you look at this particular triangle, LPM, you'll be able to see the following. LN equals to NP given. LO equals to ON, or OM rather, and that's radii. What else? So, well, you don't need anything else, right? You basically got the midpoint theorem here. okay? Because you now got Ln equals to Np and you've got Lo equals to Om. So this means now that NO is parallel to PM and NO is half the length of PM. But because PM is equal to MS, so NO will also equals to half of MS. So that's also done. So learners, let's go write our solutions down. So for 8.1.1, determine with reasons the size of each of the following angles, MOS. So now I'll just go and write down MOS is going to equal to 62 degrees. So I'm going to write MOS. MOS will equals to twice MTS. MTS, which is equal to 62 degrees. And then I'll write my reason here, angle at center equals to 2 times angle at circumference. And the next one, L, so that one is A, right? So let's go look at B, L. So we want to find L. So once again, we'll write L is going to equal to T. So we'll write L is equal to that angle T, which is equal to 31 degrees. And our reason will be equal chords subtend equal angles. That's done. Now let's look at 8.1.2. Prove that ON is equal to half MS. And this is now, remember, we said the midpoint theorem. So therefore, let's write our statements. So the first statement we write is Ln equals to Np. So 8.1.2. So we'll write Ln, this line or rather here, yeah, Ln equals to Np given. Ln equals to Np, and that was given to us. And then the other one we'll write is Lo equals to Om, radii. Lo equals to Om, radii. Remember, radii are equal in length. Radii. And now we've got the midpoint theorem, so we'll say, therefore, what can we conclude? Well, now we can conclude that NO is half of PM. NO is equals to half of PM. Now, we could have also been asked to prove that NO is parallel to PM. And remember, the midpoint theorem says that if Ln is equal to Np and Lo is equal to On, then NO is half of PM. NO is equal to half of PM. But also remember that NO will be parallel to PM. So we could have been asked even to prove that the lines are parallel. Another way that we could prove that NO is parallel to PM is we could prove converse here of, remember, what are these angles here? A 90-degree angle there, 90-degree angle there. So we could prove converse corresponding angles equal. Okay, so that's just additional questions that could have been asked in this question here. So let's complete our solution. So NO is equal to half PM, and we'll write down the midpoint theorem. But what do we know? We know that PM is equal to MS given. So we'll say PM equals to MS, and that was given to us. Therefore, we can now conclude that ON is going to equal to half of MS. That's our solution. ON equals to half of MS. ON equals to half of MS. And that's now done. So in question 8.2, it reads as follows. In triangle ABC in the diagram, K is a point on AB such that AK is to KB is 3 is to 2. And then M are points on AC such that KN is parallel to BM, BM intersects KC at L, and AM is to MC is 10 is to 20. In a question like this, it's very important to make sure that you understand your ratios quite well. AK is to KB is 3 is to 2. So let's put that on our diagram. AK is to KB is 3 is to 2, and we normally will now represent that with a variable. So we'll say 3x is to 2x. Now, if you have to look at this, what are they testing? Ratio and proportion. If a line is parallel to the third side of a triangle, it divides the other two sides proportionally. So this will be 3y and 2y respectively. They also tell us here that AM is to MC is 10 is to 23. Therefore, if you have to look at AM, and if I have to go this way, AM is to MC is 10 is to 23. I'm going to call that a different variable, and I'm going to call that 10k and 23k. So if you look very carefully, we've got all our different sides in terms of ratios. Let's go see if we can answer this question. Determine with reasons the ratio of AN over AM. So AN over AM is the same as saying the ratio of AN is to AM. So AN will now be 3y and AM is 5y. So that's going to equals to 3 over 5. CL over LK, CL over LK, and that's now going to be 23k. So that will be, so we can now say it will be 23k, and here we need, see KL, we need NM in terms of K. We don't have it yet. So what we're going to do is we need to write this in terms of K. Let's see if we can do that very quickly. Well, we now have the ability to do that because we got AM, which is 10k. Let's write that down. 10k will equals to 3y plus 2y, which is 5y. Therefore, we will now have the following. See, we bring the 5y on this side equals to 10k. Let's say y is equal to 2k. Therefore, 2y will equals to 2 times 2k, which will be 4k. So this now 2y will equals to 4k. So therefore we now have our solution. Cm over Mn will equals to Cl over Lk, because these lines are parallel. Kn is parallel to Bm. Remember, line parallel to third side of triangle, or you can say the lines are parallel and prop theorem. So therefore we got 23k over 4k, which will be 23 over 4. So let's quickly go write our solutions down. So for 8.2.1, my solution is now going to be as follows. So the first thing that I'm going to write down here is that, what am I given? I'm given that AK over KB is equal to 3 over 2. Right, so I'm going to write AK over KB. So let's write AK over KB. So AK over KB will equals to AN over NM. AN over NM. That is because KN is parallel to BM. Therefore, let's write AN over AM. So we got AN over AM, we got 3y over 5y, which will equals to 3 over 5, or 3 is to 5. And that's our first solution, 8.2.2. In our second solution here, we say that we must write the ratio of CL over LK. We've got our answer already. We just need to write our statements. So my first statement here is going to be as follows. So I'm now going to write down what's given here. AM over MC, AM over MC is equal to, so AM over MC is equal to 10 over 23. And what did I call it? 10K. So let's write it down. 10K over 23K, that was given. So therefore, what did we write next? We said that 10K is equal to 5Y. 10K equals to 5Y. And then we swap them around over here, and what did we write? We said Y is equal to 2K. Therefore, Y is equal to 2K. So 2Y will be 2 times 2K, which is equal to 4K. Now from there, we said that CL over LK, CL over LK is going to equal to CL over LK is going to equal to CM over MN. CM over MN. And that is because Kn is parallel to BM. So Kn is parallel to BM, or we can say line parallel to the side of the triangle. And we'll write down here the prop theorem. Okay, so even here we can write down also the prop theorem. And therefore, what is Cm over Mn? So Cm over Mn is 23K over 4K. 23K over 4K. K and K cancelled, so we left with 23 over 4. So we can conclude that CL over LK is equal to 23 over 4. Learners, if you have not subscribed already to JL Maths, subscribe to JL Maths. Also like my Facebook page, Justin Lazarus Mathematics. You can catch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.